The corpuscles which constitute the appearance of form are little pumps which pump themselves into closer proximity to other corpuscles when they are generatively strong, and pump themselves away from other corpuscles when their generative ability relaxes. When generative corpuscles pump themselves together in a cohesive mass, they retain that position by the high pressures which their many pumps have generated. All of the corpuscles of the one substance pump themselves into the various states of potential, which we call the elements of matter. Chemists call these little corpuscular pumps ions. When chemists subject any substance to the strain of a potential so far removed from the correct potential position that its surface ions cannot stand the suction, the surface ions lose their hold and fly away. Chemists call this effect ionization. Let us assume, for example, that a piece of silver, 803-D, is subjected to the suction of a very low potential such as nitric acid. The piece of silver would gradually disappear. Its surface ions would fly away with explosive violence, thus raising the lower surrounding potential. As the nitric acid charges by impact with an absorption of the silver ionic discharge, the process of ionization diminishes. If there is enough nitric acid to completely ionize the silver, If there is enough nitric acid to completely ionize the silver ions will expand into disappearance as a cohesive solid. In this event, the generative ability of the mass of silver has been entirely overcome by the unwinding power of centrifugal force, which has thus been placed in control. If a piece of any metal which is of a lower potential than silver, copper for example, is inserted into this solution, the silver will reappear and the copper will disappear. The reason for this is very simple. Copper ions, being of lower potential than silver ions, have less ability than silver to hold themselves in the possession of a cohesive solid. They therefore succumb more easily to the expanding power of the lower potential. The strain of resistance against the unwinding power of centrifugal force is thus removed from the silver ions and allows them to reform into their crystallic position, but not as a solid lump of silver. A solid substance, when ionized by being subjected to a lower potential position, even if regenerated, will not come together again as a solid while in a lower potential position. To reform as a solid mass of silver, with the same internal surface pressure and the same power of cohesion, the crystals would have to be resubjected to the pressure of the high potential which caused the original density. This could only be done by bringing the crystals to their melting points and allowing them to reintegrate their systems under such a pressure. Now I'll read what's on this page. Ionization percentages and example. Hydrochloric acid 92%, sulfuric acid 61%, phosphorus acid 27%, silica acid 0.0002%. Anyway, I will read what it says on the bottom instead of what's in that circle. Ionization decreases as positive charge increases. Positive charge, centrifugal force, general activity, and contraction are attributes of mass appearance. Ionization is an attribute of mass disappearance. Ionization, therefore, increases as negative discharge, centrifugal force, radioactivity, and expansion increases. All effects of motion obey the orderliness of the formula of the lock potentials. Ionization is a disintegration effect of motion, and the ratios of disintegration are in the direct are in the direct of the universal as those of integration are in the inverse. Now, next page. A metal of low potential, such as sodium, will ionize with violence in water, but a metal of high potential, such as aluminum or nickel, will hardly be affected by water. Ionization is a disintegration process, just as radioactivity is a disintegration process. Both of these effects of motion are the attempts of nature to redistribute accumulated high potential into lower potential. This planet, for example, while generating energy from the Sun, and the inner planets Mercury and Venus, is also discharging radioactive emanations in the direction of the planet Mars along the increasingly tangential pressure lanes of the system. It is proper to define this discharge of potential from the planet, which is approximately in its proper potential position, as a radioactive effect, for it is normally discharging that which it is normally generating. If, however, some giant hand should remove the Earth far away from its potential position, into the low-pressure position occupied by Saturn, for example, the Earth, assuming for the moment that it did not explode, would discharge its potential so furiously that the process would then be termed ionization. It would be losing its particles in such clouds that it would be quite analogous to that of a piece of soft metal suspended in a strong acid solution. A good example of what would take place under such conditions is seen in the comets, which leave vast trails of ionized material in their wake or push them ahead of them according to whether their direction is toward or away from the Sun. The trail of the emanations from a comet cannot properly be called radioactive emanations because the process is more nearly analogous to the chemical reactions which we call ionization. Ionization, therefore, can be understood as that process in which a high potential is placed in an environment of very much lower potential and thus more quickly subjected to disintegration. The process of ionization is a quick and abnormal return to disappearance in plane in the return journey to the southerly zone of expansion. Ionization is an abnormal replacement of that which electricity has displaced. Radioactivity, on the other hand, is a normal replacement of that which electricity is generatively displacing. All substance is radioactive. All substance is emitting ions. A normal outflow of radioactive emanations, in accordance with the normal ability to generate ions, could be termed a radioactive effect. A piece of radium, for example, is generating higher pressures by pumping the ions of lower potential into its centrifugal vortices. In a lesser degree, it is ejecting ions centrifugally, hurling them away from its vortices at a speed approximating 180,000 miles per second. It is possible for radium to generate and emit its generated ions in the form of incandescent projectiles of inert gases in the potential position occupied by it on this planet. If this piece of radium were in the position occupied by Venus or Mercury, both its general activity and its radioactivity would be increased 1,000-fold because of the environment of its high potential position. On the contrary, if this piece of radium were in the position occupied by Neptune, it would disintegrate by ionization to such an expanded volume that both its general active and radioactive powers would be correspondingly reduced. The accompanying chart explains the relative ability of mass to hold itself together through cohesion and to tear itself apart through the release of surface tension pressure according to the law of the formula of the locked potentials.